give you a quick intro to why the class is happening online for the first few days. Is I'm actually at a field station right now, and I don't know if some of you can actually see. Um, that's the view outside the window. This is a fjord, fairly remote fjord in Patagonia. We're here for one more week. So what this means logistically is just the next class will also be on Zoom, and then afterwards everything will be in person. Uh, I think now I'm already seeing we have both the students at Stanford and then the broader global cohort. Many of the people that are connecting are also mentors in the course, so I'll kind of do quick introductions to people who have been engaged in the class. And since this is a large enough cohort, why don't we get started? So officially welcome to Frugal Science 2026. I'll talk a little bit about the history of this class, the logistics of how it works, but I want to dive in into what we will end up doing and try to achieve in this quarter, which is the next 3 months we have at hand together, kind of right away, because often enough I've heard from students that, oh, we all wish we had more time in the class. So I think we're going to try to do some of the introductions and getting to know each other offline itself. So just a couple of logistics before we start. Uh, there are sort of two terms that I'll often use. There are students at Stanford that are taking this class where we will be working all together in a physical space. And then there is the term that I'll use, a global cohort, which is everybody else around the world who's joining and taking the class. There is no difference between these two cohorts. And what I prefer is that teams will form for the projects that are across any time zones. I'm seeing some people's mics are on. I would love for you to turn your camera on and switch your mic off. And I think otherwise Enrico has the superpower and he can mute anybody. It's really, really fun to see people's faces. So if you can turn your cameras on, uh, we'll do a quick round of introductions. But just so you know, this is uh, the course or the purpose of this class is to work together as a community trying to solve problems in a context of cost and scale. So this is not watching a soccer game from a sideline kind of a class. It is you have to be actually on the field. And what I mean by that, it is a project class. At the end of the day, no matter how much you listen in, yes, you will absorb certain sets of ideas. You might get inspired. But if you truly want to learn and engage, consider this as an invitation to truly starting on your dream project. So that's kind of the first thing I want to say off the bat. The amount of time you spend in the class depends on you. That's really your passion. The projects get chosen based on your interest. There is a lot of support. There are many mentors that are joining. There's also no difference between students and mentors per se. There are many experienced people that are postdocs, many faculty actually join the class. There are people who have taken this class before, so they've sort of gone through this process. Depending on fields of interest, I'll invite many mentors from around the world itself. Uh, so what's important here is we have a deep culture of respect for each other, primarily because all of us are bringing a completely different lived experience. And we are bringing kind of our own experiences and how we have lived through certain class of problems that we're passionate about. So I want to dissolve this background between who is a student, who is a teacher. I think the more time you put in something, the more you will learn. But it's also very important because many of you, as we will do a quick survey, are from completely different parts of the world. I'm looking through a little bit of time zones. I see India is represented quite well. Uh, Michael, I'm super happy that you're connecting from Madagascar. I see several people from UK. There is Ghana. If your time zone is not represented, try sharing that on the in the chat. That way, we also have a sense of I'm hoping this time works for everybody who's planning to take the course. It is important to spend some time together, so we shifted the time a little bit. Couple other quick things on logistics before we get started. As I said, there is absolutely no leniency on thinking about disrespect. So I think if you ever feel that certain interactions with people were not respectful, please reach out to me. I don't have neither the time nor any leniency around. I think unless we can bring deep sense of respect for each other, this course is not for you. We are friends trying to work together on difficult problems. So you will have difficult conversations. That's not an issue at all. But please make sure that you approach every conversation with a sense of empathy, with a sense of trying to understand things. And we have a very simple culture, which is a culture of and because we will be openly sharing ideas. Uh, Important to make sure that you always add to the ideas. There is this two types of cultures, an and culture and a but culture. We're going to remove the but culture, keep that behind. There is always a reason to tell why an idea doesn't work. Try to bring an and culture to the table, even if you are critical of certain class of ideas and approaches. We will push each other, we will push each other's buttons in all kinds of ways, but do that with a deep sense of respect. And I think you will know the frugal science is a little bit more like a family to me rather than a class. So it's important that if you are in this inner circle, these are friendships that will grow for years to come. You don't solve important problems in a day or two. You actually dedicate your lives to them. So, this could be for some of you who have already dedicated lives to important problems. And for some, this might be a starting point. But I think this is the only time I will say this, but it's very important to me that you take this to heart. I know some of you might be connecting and you're not sure if you can take the class. That's perfectly okay for the first week. But starting next week, what I would prefer is both for the people who are joining in capacity of mentors, and I'll be bringing a lot more mentors in, so you'll start seeing people with very different background than academic backgrounds in this cohort. Once I've chosen the class of problems, we bring a lot of mentors in. So that'll start to happen. There will be guest lectures associated with this, but try to figure out if this is the right time in your moment of your life to dedicate 3 months to solving and tackling something that you have cared about for a long while. If that is not the right time, it's also perfectly okay. All lectures are recorded, but then I can't have you working in a team because your team will start depending on you. And so it's a little bit important to see that you have a minimum amount of time that you're dedicating to the class because really it is a project class. Um, Other bits of logistics, we have a lot of different ways. Of course, we will have always a Zoom connection for the global cohort to connect. We will have that as standard Mondays and Wednesdays. And then Friday is a working day. So Friday will be available with quite a lot of open slots, but they will be working as teams. I think within the third week or something, we would have divided ourselves in project teams. So that would kind of initiate and get started on that you will be interacting with a subgroup of this cohort that's here in a much more stronger way. Project teams usually range from minimum 3 people to 5 or 6 people, not more than that and not less than that. that will be completely up to you. It will be organic based on the problems that we actually care to choose. And then the last logistics is I totally forgot. I'll introduce myself. You might be wondering who is this person talking. So my name is Manu. I'm a faculty at Stanford. I've run this course now for this is the sixth year in the going, and this comes out of a kind of a large scale research program that we run at Stanford, but across the globe with partners in three broad areas in health, environment and environmental monitoring, and now more and more climate change and oceanography. And then the third piece of the puzzle is science, science communication, science education, and more trying to figure out what to do with the anti-science movement that's going on around the world. So you might say this is like the broadest spectrum. I can't believe it. You could fit any kind of problem into this framework. But the reason I teach this class is just we have learned certain lessons of how to approach problems like these. We've been successful in scaling a few projects. We are trying to scale new projects all the time. Although we're physically based in Stanford, we work around the globe uh, and actually in many of the countries that some of you are connecting from. And so I think one of the frameworks is the class is a miniature version to share some of the lessons from the last 15 years. It's very informal. I have a course syllabus, I have certain sets of things that I want to share with you, but it's really our interactions and conversations that will drive the directions we will go. And the way you should think of this class is you might be coming from a very design background and kind of a social context, but you are lacking certain technical skills to execute. So that's one category of a person. Sometimes there is the complete opposite. You are incredibly technical. You've spent all your time learning these tools and technologies, but you often feel that you're not deploying that capability in a manner that is the most joyful for your heart. You don't feel the sense of satisfaction. And I didn't, very cleverly, I didn't use the word impact because impact, you don't know the impact of your work until a long period of time. Joyful is a very much more important term because it might be that you choose a problem that just brings you great joy because you feel in my life there was a deep reason you wanted to work on something. And that's why we choose projects that come from organically from the project. So this is two categories. Of course, all of us cannot be binned in any categories. There can be artists in this class. You can come from any discipline. There is no requirement. When we build teams, we try to pair them in a manner that you have different kinds of people, and especially different time zones and different countries, so that you get a chance to work with an international community itself as well, and you feel certain times grounded in the problems that you might actually tackle. So getting to know each other will become very important because of that. Okay, that's all I want to say about logistics. Let's have Enrico do a quick introduction because you'll be hearing from Enrico quite a lot. So, Enrico, could you just briefly introduce yourself and then I'll introduce the online platforms before we get started?
Yeah, sure. Hi, everyone. I'm Enrico. I'm a second year physics grad student in Manu's lab, and I'm currently working on some ocean instrumentation applications. And so I'm very excited to engage on the ocean related projects that might arise. And I'm happy to be contacted via email.
And then Enrico, I think there will be many mentors, Enrico being one, but the all the logistics, there is some amount of logistics in the course. That will be me, Enrico, and Alex, who is out on a boat right now, so he can't connect, but he'll connect starting next week. But one of the things is we will use Notion for all of our lab work and Discord for most of the logistics, and you will hear about that offline. So I'm not going to spend too much time. Okay, so I want to get started, but before that, I want to hear and kind of one of the things that will be useful is I know the participant list is what it is. Usually, we end up getting a steady stream of people, and I don't know what that steady stream would look like. So I'm going to do introductions. We did introductions in the Stanford cohort. I'm going to wait for a week or two before we do introductions from the global cohort. But one of the things that I would love for people to just share is in the chat, if you can type your background, just so that people have a sense of, and if you want, so 3 words to describe. One is, a discipline, or how do you describe yourself? You can describe yourself as a nurse. You can describe yourself as an architect. You can, one word that describes you. Another word you can write there is country. And then maybe the last third word would be a problem domain. You might be very excited about doing something in women's rights. You might be very interested in thinking about, conservation. It helps everybody else see the breadth of who all is connecting, and then in a, 2 or 3 classes afterwards, we will actually do one-on-one introductions. I just want to get started a little bit and put the framework in place in what we are going to try to do. So today I'll kind of transition to some material that I want to cover. But if you were to just write, I really like that. So Raza just wrote biologist, US, and cardiovascular health. Uh, I see Akshay just joined material science. And I think try writing certain sets of, the last doesn't have to be a single word, it can be a few words. I see an oceanographer is connecting. I know Serena from Hui, that's related to water quality. I see an economist joining on the threads of sustainability. Um and I think one of the important things that I will ask and put you all on the spot many times is you have to be completely free and feel comfortable expressing yourself. And so, in that sense, it becomes very important. Don't feel shy at all in sharing. So, Michael just joined as a reef restoration in Madagascar. Uh, Michael, I have to talk to you about diving spots in Madagascar, maybe after the call. There's some incredible reefs off the coast of Madagascar. Period poverty, Anjana. I'm reading a couple others. Water is clearly an important one. I see Hugo is joining. He's a researcher, and the context from water in Chile. I have air quality and schistosomiasis, cognitive sciences, hydroponics. Oh, we have a participant from Ethiopia. I see a friend of mine from Nigeria, parasitology. So, you can immediately look through this list and be overwhelmed. It's like, oh my goodness, what are we going to do? Do we even have anything in common? Do we even all belong in the same room? And this is where you have to trust me that we all do belong in the same room. It might turn out that it's the most diverse group of people that you've had a conversation with. But imagine if we all could be sitting on a dinner table, a very large dinner table, and talking about things that you feel passionate about. It might turn out that in this group are just some of the most incredibly important problems that need to be solved, and simultaneously the skills that are needed to solve them. And this is sort of what I find very beautiful about teaching this class every year is more and more my resolve that at the end of the day, what matters is the problems that you bring to the table and a very diverse view of how you might tackle them. It's perfectly okay if you end up working in the class on a problem that is not your problem domain, that is not your expertise. This is a little bit of a teaser of how you feel that you, as scientist, or as a designer, or as a social scientist, or as an activist, can engage in problems that you're passionate about, even though you don't have the depth as yet to develop on them. So think of it as your stepping stone in some sense. It's perfectly okay if you end up choosing a faraway problem. I'm actually super excited to look at this list. I love the wannabe geek is a very good framework. I see the that's a comment from the G. I prefer people using their real names. I think identity is very important. So in case if you're comfortable, it's actually very valuable to kind of share backgrounds and other sets of factors. Okay, so I think this gives me a good framework. This is probably the most diverse class that we have had from countries, from kind of backgrounds. Much of what we have done in the past is also documented on this website called frugalscience.org. So you can have a chance and you can take a look at it. That'll actually become very useful in this framework. Okay, so I think uh, unless there is any burning logistics question or something that somebody wants to share from the bottom of their heart, I'm gonna get started on some logistics, but we often do a little bit of an open mic. So any questions that people have, uh, it's anything that people want to share in terms of sort of stories of how they heard about this class, anything that might be relevant for others to know. I'm just using this as an icebreaker so you always feel comfortable interrupting both me, because I can go on these monologues sometimes, but also just you feel free to openly share what's on your mind. I think one important thing is if anybody is below 18 as well, if you're joining as a high school student, do let me know. We have to do some paperwork to just make sure that we will give you a form that you're comfortable and you've asked a guardian to engage. Uh, I don't see any hands, but if that was the case, you can also tell me privately. You don't have to say here. But just send me a message, and then I'll send a message to kind of folks on some of the forms. If people are comfortable, the introduction forms that we had requested for people to share, if you're comfortable, we'll share this internally in the group. That way, people have an understanding of the kind of interest others might have. Okay, so since I don't see any raised hands, I want to get started on why we teach this class and some of the maybe we'll spend a little bit of time just diving in a little bit deeper on some of the questions. Uh, and I see there is a question, what dates the sessions? Yeah, just to be very clear, Mondays and Wednesdays, we meet for an hour. But really, much of the action of what we do will be in project teams, which is all across Friday. We have project meetings and we meet in subgroups. We might have special lectures on Fridays that will all be recorded so you can engage. And I already know several of the folks, so you have incredible background in specific areas that I really want you all to share itself as well. So we'll do that all on Fridays would be a really flexible kind of a day. It's a working day. Uh, and there's physical lab spaces. If you need help finding a lab space for your project, I will work to find a local fab lab or a local community in which you could physically also find some space. I know many of you are connecting in a few universities, Ashoka in Ghana. If you need letters for your local university to give you access to machine shops and other factors, we can do something like that. We can do some legwork to make sure that you have physical lab space. Actually, maybe just one show of hands. How many of you are PhD and above? That way, I know you have potentially some lab space that you can use. Uh, and then it'll give me a framework of sort of the division. So I see lots of thumbs up. But yeah, maybe a smaller group of people. Or let me rephrase the question. How many of you have a little bit of space that you can dedicate for the project that you're working on? Uh, or do you need help getting some space? Uh, So I see lots of thumbs up, and I think, yeah, maybe Enrico, you might be better at. There's lots of thumbs up floating, which is
I also see the floating.
yeah, okay. We'll have to figure out. Maybe this is a question we should ask. But if people need help, all I'm trying to say is we'll work to figure out to get you some space or help you create in your own garage a little bit of a space and how to create a small workspace for yourself. Because I think workspaces will become very important as the projects actually continue. And then these are the types of questions you should be thinking about. We will have a budget for every project, and you can receive that budget. I can't say what number that will turn out. I'm still trying to raise some funds. But at the end of the day, I think one of the important things we do is we release budgets for projects as the needs grow. But it is actually important to be thinking about funds because these are real world projects, and I really want to make sure that the often enough I have thought about this that if you are really serious about a problem, funds is not kind of the criteria that limits you. It's your time. You're all too busy doing other things. And the goal of this class is to divert some of your attention to problems that are anchored in society in a manner that, unless you actually tackle them much more practically, you might not get to them. So it's a little bit, I would say time is a bigger problem. We will help find funds for specific projects depending on how they grow. So I think this is something that we can handle and tackle as the time is right. Okay, I think with that as in background, and unless there is a burning question, I want to jump to a little bit of a few examples and end with kind of a problem and how we will approach trying to figure out problems that we will work on. So let me share my screen to show you just kind of a framework that we've been thinking about for some time. Um, I think, let me just say a little bit of a background story. Uh, I grew up in India, and one of the things that I've often felt is we had all the access in the world to kind of get the kind of technical know-how and try to uh, really plugged in into this what often is called as the learning cycle. It was often very obvious, oh, I need to do this, now I need to do. What I lacked growing up often enough was agency or kind of this perceived permission to work on what I want to work on. It was often about, I need to get good at something so people will allow me this agency. And at the end of the day, you end up realizing when you grow up, and we're still all growing up, that that agency is not given by anybody, it's actually taken. And what I mean by that is I was very passionate about certain sets of problems that I cared about, but it was my job to take the time out and actually start working on those sets of problems. So I think the first thing that I want you to take away from this class is nobody is ever going to give you permission to work on what you are passionate about, because that's not something someone else can do, interestingly. So this is not about trying to figure out whether this fits in your PhD, whether it fits in your career path. It's about trying to figure out, are there class of problems that if you tackle them, they bring joy to you and they bring a deep sense of satisfaction. And it's also not about success in some sense, because you can choose a very hard problem that'll take a lifetime for you to solve.
Sorry,
Oh,
Manu,
did I
I
get?
accidentally muted you. Yeah, sorry
Oh,
about that.
that's okay.
Okay.
Am I unmuted now? Okay. So
Yes.
this is a very important photograph. And I don't know how many of you recognize an object in this photograph. Uh, Anybody can shout out if you recognize the object. Did you guys see that full scope, right? So this is a
Yeah.
photograph that taken by a village. Someone that I met primarily because of these full scope programs in a rural village close to Vellore. And kind of, it's a photograph that haunts me. I'm going to show this photograph one more time and I'll tell you why this photograph haunts me. And it'll become clear in a second. So that's the photograph. And one of the interesting things about this picture is it expresses joy to me. Here are kids enjoying science. So people that say that, oh, uh, it's hard to bring science to communities, I often show this picture. But this picture also haunts me in many ways because this picture is a result of 10 years of our work. This is the 10th year anniversary of Full Scope. I'll talk a little bit about what Full Scope is and why we built it, but it's a tool that allows people to do microscopy, a little bit like a pencil for microscopy. For a couple of dollars, we can bring microscopy to people. But I had this realization a couple of years ago that it took us 10 years to be where we are. I think now the tool is in the hand of 5 to 6 million kids around the world, but there are 2 billion kids on the planet. So this photograph both haunts me and brings me joy at the same time because you can see this massive line of kids, even for a tool that literally costs $2. So you understand my problem that I had thought that we crashed the price of this instrument by three orders of magnitude. We went from $1,000, $10,000 instrument to a dollar instrument. And still, it's not something that the world doesn't change just because you create something. You still have to think about processes, you still have to think about distribution, we still have to think about how does even a kid anywhere in a corner of the world actually even know about this tool, how does it reach, what does it actually mean for the person. So often enough, the reason I'm trying to say this is, to me, frugal science is about that you work backwards. You have a vision in your mind of what you want to see in the world, and you work backwards from it to say that you're not going to stop until that is true. And so, to me, that picture for microscopy has always been this idea that we carry pencils around us in our pocket. Nobody tells me or complains about the cost of a pencil or a pen. But if you look back in the history of technology, and actually we will use ballpoint pens as a case study, let me ask anyone, shout out how many ballpoint pens are made every year? Who wants to guess? Actually, this is a good moment. What do you think? How many ballpoint pens are manufactured every year? 20 billion. And there's only 10 plus 11 billion people on the planet. Anybody else? You can just shout out or type.
5 billion.
5 billion? 40 billion. It's 1 trillion. No, not 1 trillion. Okay. The assignment today, we will do something called by the numbers at the end of this class and also in the next class, which we will really think about our problems very quantitatively, which is a skill that you have to bring to the table from physics. But it's very interesting when you start thinking about these sets of numbers and you realize there was a very famous patent in ballpoint pens. Previously, of course, ink pens were present and then ballpoint pens exploded to the scene. And only a few manufacturers could actually manufacture the precision of the ball that goes in the ballpoint pen for it to generate the kind of smoothness that the pen would work for a long time. And nobody else could replicate it until a long time after that process was replicated. And that's what crashed the cost of ballpoint pens. And suddenly, pens became such a commodity that I think you're right. Billions is an easy number. It's not in tens of billions, but it's a couple billion, to a point where now they have become a problem. Plastic pollution, because people will do use and throw ballpoint pens now, that you go sign once, while a ballpoint pen can operate and make a line that's a couple of mile long. That's what they're tested for. It's actually remarkable as a technology. What you're getting for $1 or $2, a single ballpoint pen can make a line that's a couple mile long, and they're tested for it. And the level of precision that goes in manufacturing, and so you can immediately see the scale came from many inventions and technical frameworks that had to be there, but you had to operate and be thinking about that scale before you start solving a problem. And that doesn't work out in the same way for ink pens, for that matter, or many other sets of things, but works out for pencils. There's a beautiful book just dedicated to design of a pencil. And so the core of this class is you start looking at objects that you see around you in a different light. We have to learn from things that have scaled and pick up ideas and principles to say, why is it that this object? So the same thing could be asked for bicycles. It's actually, I mean, bicycle as an environmentally friendly technology is such a powerful, I would say it's an iconic frugal science tech. Uh, but not everybody can afford a bicycle. For a bicycle, I had always thought that, oh, every human should be given a bicycle when they're born. That would be kind of a nice thing to do as a environmentally friendly thing. Like you get one gift from the government of planet Earth, you get a bicycle. And there is actually only 700 million or so bicycles on the planet because bicycle manufacturing and all kinds of challenges. It's we still haven't really cracked kind of a framework around how bicycles should be printed. So rather than all these humanoid robots that the Silicon Valley companies are making, I would much rather crash the price of a bicycle because that would be very powerful in terms of thinking about what it means as transport for many people around the world. Uh, and I think one important factors to consider in this framework is I showed you that picture. That's sort of our own internal way of thinking. But for the next couple of months, I really want you to, we will do case studies for a few things, but I really want you to document everything around you that you see that has scaled and ask yourself a question, why did that scale? uh, and work backwards. And this is sort of what we think about. The principle of frugal science for us will always be not just solving problems, but trying to solve problems with scale. And I know some of you study economics, and you can then come up with all kinds of frameworks associated with it. Uh, the other quantitative framework that we will think quite a lot about is kind of these trade-off between performance and scale, and asking yourself a question in a cost kind of a context is what is the right performance do you actually need to solve a problem? And it's not so obvious until you deeply understand the problem. I mean, diagnostics is a classic example of this. you know, when COVID was happening, there was a huge discussion about should we massively implement RDT tests or not, if some of you remember that. And then there were all these other tests that were molecular that were much more sensitive. But at that time, the need of the day was to rapidly deploy low sensitivity tests because from a public health standpoint, it was still actually a very important thing to be able to be thinking about the wave. And so, ironically, it was a great example, and RDTs eventually won. FDA approved it. Globally, they were implemented. And early on, there were lots of pushback from many doctors that, why are we deploying these tests in public's hands? Because this will cause all kinds of burden on the system. There were all kinds of arguments to be made, but it was an important question to ask. It's not so obvious when you're trying to solve a particular problem what is the performance you actually need. And I'm not saying that there is always a hit in performance when you're thinking about cost of an engineering solution, but what I'm saying is you need to think about cost as a very important design parameter. And it might turn out for the project that you're working on that we will come up with 1,000 ideas. And one of them will strike, not only will actually achieve the best possible performance, but would also have a new scientific principle and hence you might be able to actually beat everything that's been done. And frankly, cost in our society is an arbitrary number that somebody who owns that technology has decided to force on people. So I don't really understand cost. If an economist can explain me one day what cost really is, because I see cost is a way of it's there is a will of a person that is implementing these sets of ideas. So I think we will try to think about cost effectively in context of markets and what the need is and could you scale it. But at the end of the day, there is also a lot of wiggle room to be thinking about. Uh, and for that reason, it might turn out that very early in a project, we will make a decision that the right way to scale an idea is open source, for example, or mass manufacturing, or some other approach to bringing things to market itself. And you might think that, oh, I don't even know what I'm going to be building. Why am I thinking about these strategic things that are needed 10 steps down the road? And what I'm trying to say is, many a times you have to make those decisions first to constrain the ideas that you care about early enough. So if you're going to be designing something for a rocket engine, maybe your cost constraints are not that strict and you have a lot of wiggle room in the idea space. But if you're designing a toy for a kid and a kid only gets $1 as a monthly pocket money, guess what? If you don't make it for a dollar, it's not going to be in the hands of anybody. And so suddenly we will talk about cost in a very need basis for the and especially the communities that you'll actually be choosing. And that brings me to the context of communities. I think the next picture that I want to share with you is right here. Uh, this is an interesting picture, and I know there are a few students joining from Ghana, and I'm going to have them share a little bit. But this is a photograph I took in Ghana. I could have taken this photograph anywhere in the world, actually, because we do a lot of work in malaria, and I'll talk about malaria quite a lot. And this was a temporary clinic that we visited. And one of the challenges is choosing a community or an area that you will be thinking about early. And, I could also just show you another photograph. This is another photograph from Madagascar. I know Michael is joining. This is close to Ranamafan. There's something very special about this photograph, which is the people up in the front row of this photograph are actually three doctors from the area that are hiking roughly between 12 to 14 hours on foot to actually reach a clinic. Uh, and why I'm showing these two pictures is I could be working on a problem, but if I did not choose a specific community that you are trying to design a solution for, you might never consider this as a constraint. For Hugo, for example, I know he works in remote lakes in Chile. You have to choose that context first and then think about a class of a solution. And it's a little bit backwards because it feels like everybody. Because unless you chose your context well, you might miss and not actually solve a problem for anyone. You are allowed to broaden the applicability of your ideas later on. So I think one thing we will do early on is the first assignment that we will do. If you're trying and excited about, I'll give an example for Webhub's project because he's connected. Webhub and I have been working on an idea to do schistosomiasis diagnostics in school children around the world, and this was uh, you know, it's a large problem. 700 million kids around the world get infected. It's a huge issue. But one of the things that becomes really tricky is that there are certain locations around the world where the parasite exists in very high density. And so you have to be thinking about that particular location to understand that the diagnosis that you are delivering is for 500 kids per day, and the diagnosis doesn't happen in a hospital. Actually, it happens in their school, because 90% of the kids are infected. So you need to arrive in a school and basically screen everybody. And so the problem is not whether you can build a good diagnosis. The problem is how quickly can you actually scan through and identify the kids that are infected. And so it's a throughput problem, which would not be a problem that would appear if you were just looking at a primary health center, for example, or even a tertiary health center. So I think the third piece of the principle that I really want you to focus on, and this is also where the global cohort really shines, is when you're building teams, I want you to partner with people that have boots on the ground, that live that problem every day. Every year we choose certain sets of problems on mosquito and mosquito biology, the most dangerous animal in the world. But if you have never been bitten by a mosquito, I can't have you work on that project alone, period. And what I mean by that is you have not lived the problem. So you will not be thinking in the framework that a person who's just so annoyed and can't do anything about it, and you have to go by the day, and arbitrarily every other week you are sick. So it's important to find teams and partners. And I'm not saying you go experience all the terrible things that you might be working on. That's not, but you have to understand that much more deeply. And so I think this will become an important portion of why we run the class this way is find partners, and we'll bring mentors early on in the project. So some of you, I know some people mentioned air pollution. How many of you have landed in Delhi in the middle of December or January? Some show of hands. Okay, Akshaya, right there. You know what I mean. It's like smoking cigarettes, like 20 packs in one row. It just, I cannot describe how it feels, but it's this worse feeling. Your eyes are starting to burn. You cannot leave outside. And so, in some sense, don't try to choose problems from far away. You cannot have hands sort of a distance from the problem that you're trying to work on. This is going to be very, very important early on. And if you chose a problem that you're very passionate about, but we haven't found a key partner in the global cohort or in some of the mentors, we're going to dig hard to be able to find. I mean, this year I definitely want to work on illegal gold mining, for example. We just met certain sets of partners in Ghana and also actually in Liberia and Senegal, where there is massive amount of mercury poisoning that happens. And suddenly you might say, "Oh, it's a problem that you can start thinking about." But what we will try to do in the early phase of the project is really for you to feel that you have a context of a problem. And we'll do it in many different ways. But the first thing is to be able to develop that with folks that are in the thick of, and actually, in some sense, have lived experiences around the class of issues that you're thinking about. Okay, and then the last principle that I want to mention before sort of we talk a little bit about the first assignment for the class. Um, Let me show you a few more pictures, actually. I think we'll kind of do this through sets of pictures. Um, this is actually a photograph. It's a recent photograph. You can think about it, oh, is healthcare and how we deliver healthcare. You might have heard that we deliver healthcare through primary health care workers. But this is even a border beyond primary health centers where you deliver healthcare, where you show up in a box that has every possible tool that you need in somebody's household. And this is a photograph of an ASHA worker. They're volunteer workers that travel around. And actually, you might say, oh, this is in a faraway place. Frankly, this is exactly how we deliver healthcare to homeless uh, communities in San Francisco. Because many of them are not appearing and arriving. And so you really have to come and show up at the doorstep. So you might be thinking about a layer that's even much deeper than what you had previously thought about the infrastructure that's available. A lot of times in the class of problems that we'll think about, uh, you will have to rely on less and less of basic infrastructure that's being available. And that will set sort of it's perfectly okay if you solve a problem for just this interface for delivering help. It's perfectly okay if the solution is not designed for primary and tertiary health. It's actually very valuable to be able to narrow down what you might be excited about. Okay. Um, I think another thing that we will think a little bit about is the context of climate, and I want to show these two pictures associated with, you'll see I'm only choosing sets of things that kind of bother me to a certain second. So, this is, it's not a fair representation, but it's actually an interesting representation that these pictures tell stories that I want you all to think about. This is the context of malaria in some sense, and we do a lot of work in malaria. But the real thing that I want to show you about malaria, which we will talk quite a lot about, is not all problems are getting better. I think many problems are getting better. I agree that, if you look at global poverty, you look at certain sets of numbers associated with what's happening in the world, certain sets of things are indeed getting better. Solar is a phenomenal example of what is getting better in our world. Massive amount of solar is available, power is available, but this is an example of something that is not getting better and we don't know why. 2017 and 2015, we saw for the first time in the last 50 years of malaria data an inflection point where the number of cases, this is in million, so this is 230 million in 2010 to 215 million. Uh, and suddenly there was an inflection point and the cases started rising. And the current number for 2025 that was just released is actually 260 million. So the curve has gone down and then is going up and up and up. Every year it's going up. People have lots of theories about it, but there is lots of things, and the amount of money that's been put in this problem has actually either remained flat or increased while the problem is increasing. You could say this about every climate problem, every ocean problem, number of HABs in the world, number of glaciers melting, amount of microplastic that we find year after year. And it's not just that our detection capabilities are getting better. There is something fundamentally changing as well in our environment. And malaria is a really interesting example of a disease of the environment. So, one of the things we will talk quite a lot about when you are choosing problems, do you have a deeper understanding for what we often call by the numbers? And what I mean by the numbers is we are going to try to very quantitatively look at some of these problems in the early phase so you know which side of the curve are you on. Are you trying to work on a problem that is already going down and you are trying to eliminate it? Polio is a great example of that. Polio has been really on the low numbers, so it requires a totally different strategy to be able to tackle. While malaria is a interesting analogy where the problem scale will only increase with climate change. And so if you're going to design something that will be in action 5 years from now, you have to be thinking about where the puck is going to be. So, there is a context of thinking about these sets of numbers that will become very clear soon. Um, and then maybe I think this is a political statement, but I think it's a very important political statement to make, so we should make it. And I want to say this, that we are operating in a world where the rules are changing as well. And I think I don't take this lightly when I say this, that it's probably the most dangerous time in how science has been perceived around in the world. I just chose this data because I happen to have this slide around anti-vaccine movement. It's a published paper in PLOS Medicine. There is a systematic approach around eliminating vaccines. Now we have, out of the 17 vaccines, for the very first time in the US, children will not be able to get vaccines. Many of you know what happened in kind of Roe versus Wade. And again, this is another political background. I was just, and again, it doesn't matter what side of the how we should run our society side you are on, you have to be on the side of science. And I just want to share that unfortunately, the background of what we are dealing with currently is of a certain nature that we are now dealing for the first time where there is systematic anti-science. And it will matter. It will matter which projects you end up choosing. It will matter where you might want to focus your efforts on. It'll also matter to the fact that you will get a pushback in certain sets of ideas and things that you're trying to actually do, which is, I would have never thought that I would say that in my lifetime because I felt everybody was on the side of science. But actually, that has been a very challenging thing to think about. And in some sense, it sort of is a fuel to the fire in a way. So use this as a positive rather than a negative. It's very easy to get depressed about whatever is happening around the world, and terrible things are happening around the world. Uh, but to a certain extent, I think it's become much more important for us. So for the first time in the class, we are going to also think a lot more about an artistic expression. I feel no better way to connect emotionally with people for the class of projects. So when we did this project in schistosomiasis in Nigeria, we brought a Nigerian photographer with us, and he just took pictures. And I can't tell you, Weber was on that trip. I saw those photographs, and it was telling a story of water in a way that I have never seen before. And it told the story of a disease which was so playful and so compassionate, and yet being able to share. And so I think one of the things that I do want to say is we are going to try to think a lot more about not just the, throw the numbers and you assume that very quantitative logical numbers will move the needle in how people will react to the work that we might try to do. And I think very explicitly, I'll choose a few case studies of if people have case studies where art has truly made a difference in how we have been able to think about ideas, that would be valuable. I think climate is a big one, health is a very big one. The one that I like the most as a story, we'll talk quite a lot about TB. There is a massive campaign in India to make TB not a stigma. And they are TV ads and they're quite funny and they're quite well beautiful. I mean, I would say it's not always this way, but it's useful. Start building your pile of things in which you're also bringing a sense of lightheartedness or other ways that people actually care about the sets of projects that you're going to try to do. It's a very intangible kind of a thing, and it's an art that you have to develop. But I see no other way for any of these projects to succeed unless you are actually thinking about that dimension itself. And there is a very human dimension in this kind of changing world, and how, and I saw sort of the Swachh Bharat campaign is another set of an example. But try tallying some things together for your favorite art projects. And one that I will actually now show all of you because I love it so much. It happened 2 or 3 weeks ago. I wasn't planning to show this, but I'm looking at the clock. It's the introduction to the next lecture and your homework problem. So let me show you. It's going to be a 2 minute video that we're going to watch. And then I promise we'll just spend 1 or 2 minutes. I'm going to give everybody a homework so you don't get free. You have to now think about something. Uh, I had mentioned this logistically. I don't really care about any grades or anything. So you're doing these homeworks for yourself. Uh, when you do a spectacular job at it, somebody will read it. Otherwise, nobody will care, and that's your loss. So think about it as your own internal tool. Homeworks are really for you to kind of hone in your own skills. But if you do a spectacular job, you get to share it, and I'll tie it. All the things we will do will be tied to the projects that you're trying to do. But I think it is important to think about homework in a new way. You are allowed to use whatever tool you care about, as long as you own the work that you do. And it's just valuable to also share if there are any other tools that you're using. Okay, so I want to show you one video and I'm going to introduce the topic of the next lecture, and I promise you then I'll let you all go. What is the name of the video? Now I just forgot. I'm blanking. Okay, no, I know what it is. Uh, use 60 seconds, no, 100 seconds. Uh, and then in the meantime, if you want, okay, here it is.
I'm 65,
Oh,
and today
don't want
I'm
the.
trying my first Tai Chi workout.
What does the United Kingdom really look like? Each second.
No. Okay, I think I know it's here. Okay, it's called Earth in 100 Seconds. Uh, and I think some of you might have seen this. This was released by National Geographic almost 2 months ago. And I want you to sort of, we'll just first admire the video. It's only a 2 minute video, 2 minute 34 seconds, or I think it's supposed to be 100 seconds. It's Earth in 100 seconds. I'm not going to say anything. I just want you to see this video, and then we'll come back and I'll tell you your assignment. Can you hear the audio?
What are we using planet Earth for? Let's go for a walk to find out. Each second of our walk reveals 1% of land and how we're using it. The Earth in 100 seconds. Are you ready? We spend our first 10 seconds walking across a frozen land of ice. And the next 11 in desert, barren and rocky lands. Just 14 more seconds of our walk is through ecosystems that we minimally use, including only 8 seconds of intact forests. All other land is directly exploited by people. Just 1% of land is built on, but our footprint extends across the rest of the planet. Crops cover 11% of land. Over a third is fed to livestock. But for 20 seconds, we're in the woods again. These forests are managed for their timber and play a vital role in regulating our climate, air, and water. Some are great for wildlife, while much are not. But it's sad to say that we have prioritized over a third of land for producing meat, dairy, and animal products. 14 seconds of our walk is on less used wilder grasslands and rangelands, as well as cows, sheep, and goats. Wild animals could graze here. Some livestock is managed carefully so other species can flourish. Much is not. Our final 19 seconds is through pastures that we mostly use for rearing cows. Cows now have a collective mass that's nearly 10 times greater than all wild mammals combined. At a time of climate crisis and when a million species are at risk of extinction, why not rethink this mix of lands we have and how we use them? I need more trees, please. I think more nature will be greater. So what if we made more space for nature?
Okay. I don't know if some of you have seen this video. You can watch it a couple of times. It takes a long while to actually understand. But just to be clear, 100 seconds video, every second corresponds to how we use the land. 10% was frozen. And then, of course, the punchline of that is 20% or 19% of all land is for meat and just animals. And it sort of gets you thinking. The reason I wanted you to see this is the assignment, and what we're going to be doing in the next class is what I call by the numbers. No matter what problem you're excited about, you have to be very quantitative about approaching. Everything can be quantified. It can be a social problem, it can be a very direct health problem. Everything can be understood better with numbers. And so the big assignment for everyone is, I mean, you can collect certain sets of things, I'll post certain sets of things to read. But even without that, try thinking about one problem that you're most passionate about. It doesn't have to be the problem that you'll do your project on, but it might actually end up being that problem. And I want you to write as many ways of coming up with numbers that are associated. And I'll kind of say, I was going to show you guys today, but then I felt I would be too sad. I was sitting here in this pristine fjord, and a bird came by and hit my glass. The most beautiful hummingbird, and it instantly died. And I have the bird, it's right outside, and it's just the most beautiful hummingbird, and it's dead. And I've been seeing them flying around. And so then, of course, I'm going to sit down and calculate how many birds die. And I've heard this number before, but seeing it happen right in front of me while I was working, it changed how I think about it. And I know there are many simple solutions, and why have we not implemented them? But something happens to you, but then you have to have the capacity to understand. And in physics, these are called Fermi's problems. There's a massive framework that's been developed, and these are incredible tools that are at our disposal to be able to approximate an impact of a problem. So, snake bites is a great example. If some of you have never heard of snake bites, you might say snake bites is not a big problem in the world, but when you do the numbers, you actually realize it has a far larger impact than many other diseases. And we don't have antivenom, so a significant portion of people die. So you have to figure out without any data. That's the problem, is nobody's being paid to actually measure something, and that's why you use the tools of physics and approximation and mathematics and statistics to try to truly understand, could you figure out how much of something exists. Some of these you could choose as an assignment a totally whimsical problem. You know, you might, I'm going to now make up a whimsical one. I was in San Francisco recently, and I walked into a coffee shop where they were selling the coffee that you only make after it's been eaten by a cat or something and pooped out. It's like the most expensive coffee in the world. You $20-30 per cup. And then I could say, oh, I want to calculate what is my probability if I walk into a forest that I'll find a little bean of coffee that has been pooped by a cat. And then that should be, or like, if you like mushrooms, you could say truffles. Like, what is your problem? It can be something whimsical if you want to practice. Choose whatever you care about, but start with something where you truly did not know the answer. You cannot just know the answer and somebody's done the work and say work backwards from it. Then you've lost the plot. You're not able. Choose something that you feel that no, 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 I have no capacity of knowing this number. And we will then work in lecture 2 on Wednesday on lots of mathematical tricks that allow us to do. And this is a trick, it's called by the numbers or back of the envelope calculations. It's used in physics quite a lot. It's not used in social science as much. And so, kind of, we're going to take a tool from physics and apply it to social problems. You might say, oh, I go to national parks all the time. What is the probability that million people are walking in a national park, that they are bringing a microbe that could completely contaminate the ecosystem? Like rock snot is one example. It's a diatom that carries on people's shoes, and you should be able to write the numbers to understand how large could this problem actually be. And it's perfectly okay if your numbers don't match what other people have published. It's about the process. So that's the assignment. Is the assignment clear? Yeah, I see. It's called the civet cats. Uh, and I see we're already out of time, and so I don't want to hold people back. One thing we often do is at the end of the class, every class we will have an open mic. I'll hang out for a few minutes. Anybody that wants to share anything, any curiosities that you have, any threads or questions you might have, or do you just want to share an anecdote that's related to the class, or just want to hang out and say hello to friends and people? So this is now an open mic time. You don't have to hang out. And I promise you, in 2 lectures' time, we will do introductions from everybody that's joining. I want to get things started a little bit and then really sit down and get to know every one of you, because that's probably the most important thing about this class is people know what backgrounds they're coming from. But it's an open mic. Any questions, comments? If you already have an idea of what you want to do your homework assignment on, and then we will discuss things that people would have found on next Monday. So you have a week's time to do this. So I'll stop talking now, and I'm happy if somebody else wants to share a problem that they're thinking about. It's a great way to introduce yourself if you already have a problem that you're passionate about that you want to tackle in the class.
Hi everyone, nice to meet you. My name's Kelly.
And Kelly,
So
can you
the pro
introduce yourself? Yes.
Yeah, so my name's Kelly. I'm currently a master's student at Stanford. I'm doing the design program. But my background is in chemistry, so I have some science background. And for my work, I'm really trying to find the connection between these two, right? So I'm super excited to be part of this class because I'm hearing, a lot of similar themes to what I think about in design, like selecting users and constraining the problem and whatnot. But I guess for my thesis, I'm working on something a bit unique. I'm looking at metaphor use in science. So, really thinking about how these base metaphors we use can influence thinking a lot. Like they influence like what you think is possible as a solution, right? We saw this historically a lot in the development of physics and now biology. So it's kind of a very loose problem, and it's not something that I even really think of as a problem. And I find it hard to like apply numbers to it. So I'd love to hear your thoughts on this. Also, I don't know if you've read this book, but I have it on my table. So it's Sea of Cortez. I like
Oh,
absolutely love
yes.
this book, and it got me into kind of like the wonders of the ocean. And so now I'm also interested in that world.
Sea of Cortez, everybody should read it, and especially has a very deep historic background. By the way, the boat that book was written on, the Western Flyer, was just found a few years ago, rotting in Portland. And because the original book and Steinbeck's writing had the photo, somebody noticed the the captain's cabin was sticking out of the water, so they identified it. They've now refurbished it, and the boat currently is heading out, repeating the expedition, but with students. So it's kind of a real full circle. So metaphors, that's a really fun context, and I think the only comment that I can make, I have to think more about this, is this idea. In physics, we use a very powerful tool. It's called toy problems. And it's not taken lightly. It's toy problems are kind of just the right gist of a problem, just the right analogy that you can tackle that carries the gist of a complexity of what you want to deal with, but at the same time is at the heart of the problem, but is simple enough that you will tackle it with very formal tools. And I wonder in social context, I think what is the equivalent of toy problems where you already know that you have allowed yourself a compensation that I am not going to be tackling the entirety of the complexity, and that's okay. But you declare it up front. So it's not hidden behind certain filters. So that's the one thing that comes to mind. I think quite a lot about analogies between what are the toy problems that you could tackle that will get you in the right path, but for social challenges. Like, is there a toy democracy, for example? Like, you often worry about why is the democracy not working, but I want to be able to better understand the parameter space, but build and I think so when you said metaphors, I find metaphors useful in that way in finding adjacency problem, that there is an adjacence problem to it, and it might be a toy problem or might be a simpler way. Uh, but yeah, I mean, I think if you're on campus, when we meet on Friday, we can sit and chat more about it. But I think this is exactly the kind of discussions and conversations I want to have. It's perfectly okay if you feel this doesn't fit. If it doesn't fit, it's just the right kind of a thing that you're thinking about. And I mean, it's also at some point of time, I know the way I recruit people for this class is just sending messages, and it's my circles, and my circle is a very heavy science circle. So in some sense, I'm also very happy that if people recruit. By the way, you still have time. If you have a friend that you wanted to work with forever in your life and you wanted to recruit them to a class and that'll form a project team, that's perfectly okay. I think we're gonna freeze everything by next week. I had mentioned this to other people in the class before, but if you have someone that you really feel you want to work with and they would be willing, but they are in different part of the world now, feel free to invite them and see whether they are a good match. And then you are planning to work with them. It's kind of a way of doing projects with friends. Okay, any other last minute comments before we say goodbye for today? Any logistics, anything that comes to mind?
Hi. I
Yeah.
just want to, I just want, this is
Ayushi, can
just
you
a run.
introduce yourself? Yeah.
I'm Ayushi. I'm from India, from Delhi. And when you said about pollution in Delhi, I it really resonated with me because I'm a student and we had to go for exams, we had to go for classes every day in that pollution. And I really wanted something because we students we cannot buy air purifiers and everything. All we had was that mask N95. But I was really thinking we should do some Indian jugaad because yeah, that's what we are good at. We should do something, and maybe in this class, even if I'm not able to get a proper solution to that problem, I would like to develop a mindset of thinking in that way. So yeah, and also it was my birthday today, but I was so excited for this class. It is 12:16 a.m. right now, but I like the whole day I was just thinking that I'll attend that class, I'll attend that class, and it would make my day. So yeah, thank you so much for taking the session today.
We're very happy that you joined on your birthday, especially at midnight. A quick comment on air pollution. I think this is something that would be really valuable to pick up. There's enough students from Delhi and Ashoka, very easy. And then what I would say is that the field of air and understanding air has advanced astronomically because of COVID. There are already very large scale open source projects around air purification and other sets of facts. So utilizing what was developed for COVID, but really thinking about in context of indoor air pollution for context in India. Very straightforward. You can all do that in a short period of time. So I think the attitude that you should take is this is indeed a problem that would be really worth picking up. And then the other side of the story is think a little bit about also the measurement side of this is the fact that there is a lot of solutions people propose, but do they actually work? And so personalized, because I know there has been a lot of frameworks around. India just reframed their nomenclature about how they measure, and that reframing is very dangerous. You take a scientific framework that's already been established as universal, and a government comes along and says, no, 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 we're going to measure it this way just to change people's mindset without working on a problem. This is exactly what we have to push back on. So think a little bit about it's not just about the solution, it has to keep rising on the side that we cannot change our measurement standards. And in health, this is a huge issue. We don't monitor in the right way, and then we kind of change what we would think as a parameter, and then that we assume is, the problem would go away. Uh, Very relevant, lots of expertise in this room, just the right time to do it. And, in some sense, there is plenty of open source solutions already. Okay, any other last minute comment before we say bye?
Hey,
Anybody
I'm
else wants to do a
Yugveer.
quick?
I just wanted your advice
Yes.
on a problem that I've identified I want to tackle through this course. So I come from India
Mhm.
again, and the problem that I've identified is that India, being a very populated country and having a high population density, we have a problem of land in our country, and like the farmers at our country have like very small plot areas. The problem, basically, what we are identifying is the fact that we do not have enough land to grow agriculture. So my first solution was hydroponics because it requires less area than vertical farming. To further on add on to that, I've been working on the problem, but I wanted more insights, more technical expertise, and yeah, I'm currently a freshman at college, so that also I need a lot of more understanding, and I wanted your insights into this as a problem.
No, I think that's fantastic. My biggest advice would be is choose that as the problem for your by the numbers assignment and write down explicit numbers to understand, compare it to different countries, compare it to sort of what happens in 5, 10 years from now. I looked at the statistics recently 2 months ago, and it's predicted that in 5 years from now, that land area per use of a farmer is about to be halved again. So it's not just about the number now, because the way farming works is you pass the land to your children. If you have two children, it splits and it splits and it splits. So kind of focus first on truly quantifying the problem before jumping into hydroponics as a solution. Although you might end up with that, we're going to take the first few weeks when you're refining to just focus on the problem and not care about the solution as such. Because it might
Mm.
turn out that in the act of quantifying, maybe there is another way to be thinking about this problem. So this is a general advice. Often we tend to think about solutions first and problems second. And the purpose of this class is to flip that around, because our problems don't care about our expertise, but the way we come up with solutions is just based on our expertise. So sometimes you feel you have to go backwards to go forward. And it
Yeah.
might turn out that you can prove very clearly that hydroponics is the way to go. But initially, let's understand the problem. So, by the numbers, but compare India to some other country itself as well, just so you have some comparative context.
Okay.
Okay, I
Understood.
think it's 3:50. I'm gonna say bye. I have to get back to work.